Dear students, welcome back to the course on design of power electronic converter. We were doing the analysis of power electronic converters, out of which we have completed the design of buck converter. We have solved the one numerical, or we have designed one buck converter circuit also. Now, in today's lecture, similar way we are going to design a boost converter. So you can analyze the circuit in the same way as we have done for the buck converter. And today we will solve the design of boost converter. As I said in previous lecture, keep your notes ready. Try to solve this numerical by yourself. If not possible, I will give you solution in this video. We can refer the video. So here we have to design a 50 volt DC power supply with output expected is 100 volt. So this is your boost converter, 50 volt DC input and 100 volt output at 700 watt power. Design a boost converter with the following specification. Peak to peak ripple in inductor current is limited to 10% of the output current. So ripple is 10%, current ripple, and voltage ripple. Capacitor voltage ripple is 2% of the output voltage. Switching frequency is 75 kilohertz. You have to determine all these 7 parameters: duty cycle, output current and average inductor current, peak to peak inductor current ripple, inductor voltage, capacitor voltage, MOSFET voltage and current rating, diode voltage and current rating. So these many parameters we have to calculate, and we have to design this boost converter as per this given specification. So these are the given parameters. Vs is equal to 50 volt, V0 is equal to 100 volt, P0 is equal to 700 watt, delta IL is 10% of I0, delta Vc is 2% of V0, and Fs is 75 kilohertz. So we will first start with the calculating the duty cycle. So duty cycle for a boost converter, the formula for finding the duty cycle is V0 is equal to Vs into 1 minus D. So this formula is having a change. For buck converter it is V0 is equal to D into Vs, but for the case of boost converter, V0 is equal to Vs into 1 minus D. So on substituting this Vs and V0 values, we will get D as 0.5, or this can be written in percentage, 50%. So same way we can find T on and T off. We have frequency of 75 kilohertz. So total time period Ts is 1 by frequency. So 1 divided by 75 into 10 raised to 3 will give you 13.33. This is the total time period from which T on can be calculated by the formula T on is equal to DTS 0.5 into 13.33, which will give you 6.67 microseconds. T off is 1 minus dTs 0.5 into 13.33, that is equal to 6.67 Ts. So because this is 50%, your T on time is equal to T off. Duty ratio is 50%. So on time is equal to off time. Now, what is the next part of the question? Output current and average inductor current. So output voltage is 100 volt and output power is 700 watt. So we know that power P is equal to voltage into current. P is equal to VI. So from which I is equal to P0 upon V0, that is 700 upon 100, which is equal to 7 amperes. So this is the current flowing through the output resistor. Now we have to calculate the average inductor current. So here average inductor current of a boost converter can be calculated by I0 is equal to 1 minus D into IL. So IL can be written as I0 upon 1 minus D. So I0 is 7 ampere divided by 1 minus D is 0.5. So 1 minus 0.5, which gives IL is equal to 14 ampere. This is the average value of inductor current. Okay, and this inductor current is same as the input current. In is the input current, so input current is also same 14 ampere. Whatever inductor current is to be supplied from the source. So inductor current is equal to the input current, that is 14 ampere. So how we can find the load resistance? Resistance, either you can calculate V0 upon I0, because we have calculated V0 upon I, or we can calculate V naught square upon P naught will give you resistance 100 square upon 700. So the value of resistor is 14.29 ohms. Now we will move on to the third part of the numerical. You have to calculate peak to peak inductor current ripple. So what is inductor current ripple? Delta IL is 10% of I naught. What is I naught, which is calculated in previous step? It is 7 amperes. So 0.1 into 7 will give you 0.7 ampere. This is the value of ripple, delta IL, 0.7 ampere. So from which you can calculate the maximum value and minimum value of the inductor current. What is the maximum value? IL plus delta IL by 2, that is 14 plus 0.7 by 2, which is equal to 14.35, and minimum value is IL minus delta IL by 2, that is 14 minus 0.7 by 2, which is IL minimum is 13.65 ampere. Now, next we can calculate the value of inductor. So, the formula for finding the value of inductor is L is equal to Vs into T on divided by delta IL, or Vs D divided by Fs into delta IL. T on can be written as D by Fs. So L is equal to Vs by D Fs into delta IL, that is 50 into 0.5 divided by 75 into 10 raised to 3. Fs is 75 kilohertz. Delta IL is 0.7. So on solving this, you will get 476.2 10 raised to minus 6 Henry, or this can be written as 476.2 micro Henry. So approximately we can choose a 500 micro Henry inductor for your boost converter. Now, fifth part is to calculate the value of capacitor. We know that delta VC, or capacitor voltage ripple, is 2% of V naught. V naught is 100 volt. So 2% of V naught is 2 volt. So with this formula, you can find the capacitance value I naught into D upon Fs into delta Vc. I naught is given, I naught is 7 ampere. Duty ratio D is 0.5. Fs is 75 kilohertz and delta Vc is 2 volt. So on solving this numerical, we will get capacitance value is 23.33 microfarad. So as a standard value or approximate value, you can select a capacitance of 27 microfarad or 33 microfarad for this particular boost converter. Now we have to calculate the MOSFET voltage and current rating. MOSFET voltage rating is this is your MOSFET voltage. MOSFET voltage rating is greater than your output voltage. So it is output voltage or MOSFET voltage. Peak value of MOSFET voltage is output voltage V0 plus delta Vc by 2. So that is 100 plus 2 upon 2, that is 101. So your MOSFET rating should be greater than 101. Now MOSFET current rating should be greater than your peak value of your inductor current. So inductor current, average value of inductor current is 14 plus delta IL by 2, 0.7 by 2. This is the peak value of your inductor current. So when you're solving this, you will get 14.35 ampere. This is the peak value of inductor current. You should select a MOSFET which is having a current rating which is greater than 14.35. So in practical application, you can select voltage VDS at 150 volt and current ID is greater than 20 ampere. Now, diode voltage and current rating. Diode reverse recovery voltage should also be greater than your maximum voltage of the output. So that is 100 plus 2 by 2, that is 101 volt. And diode current rating is also greater than your peak value of the inductor current, IL plus delta IL by 2, that is 14 plus 0.7 by 2. Always keep in mind that whenever you select the rating of any equipment, you should take that peak value, and your rating of the equipment or that component should be greater than that of the peak value. Okay, so we have designed all the parameters. So your this is our final boost converter looks like. It is input voltage is 50 volt, output voltage is 100 volt, your output current is 7 ampere, resistance value or output resistance value is 14.29 ohm, capacitor rating is 23.33 microfarad, your MOSFET rating should be and diode rating should be greater than 101 volt and greater than 14.35 ampere, both these components, and your inductor value is for 76.2 microhenry. Okay, so these are the results. So when you're actually designing the component, you have to select a value which is greater than what is obtained in your actual design. Okay, you can use these components with equal or higher voltage and current ratings than calculated values with adequate safety margins. So this is the way we can design a boost converter for our particular application. Thank you so much for listening the video. Try to solve this by yourself one more time and reach me if you are having any doubt. Thank you.